Good morning, everyone. So today we're talking about writing addition and subtraction expressions. So some of you have already started kind of trying to do some of this on Khan Academy, and the addition ones are really kind of easy and straightforward. The subtraction ones, however, are a little bit different because the order matters. So yesterday we talked about the commutative properties of addition and multiplication. And so addition, the order doesn't matter, but subtraction, it actually does. So when you're writing expressions, you actually have to think about, what you're doing. So I'm going to go through these examples really quick, and you can copy them down as kind of like our notes for the day, and then go on to the exercises. So example 1, create a bar diagram to show 3 plus 5. And, here we have 3 and 5, 1, 2, 3. So here's 5, 3 plus 5. That's going to equal 8. And if we were asked to show 5 plus 3, that would be, here's 5, and here's 3. So yes, they're equivalent because both are 8. Here's 3 and 5. This is 8. All of these, there are 8 of them. So this is because of the commutative property of addition. It doesn't matter what the order is. So number 2, how can we show a number increased by 2? So a number, it's not being specific as to what we're saying. So a number increased by 2, we're going to want to use a variable. You could say, well, let's pick a number. Let's do 3 plus 2. But this doesn't really show, this definitely shows a number increased by 2, but when you write an expression to show something increased by 2, you want it to kind of always work. So this doesn't always work because I can't, put something else. This would be 5, but once I put a different number in at the beginning and add 2 to it, it doesn't work anymore. So the better way would be to say, a number increased by 2 could be n plus 2. That's a number that's going up by 2. And so, I can prove this using a model because I could have, let's say n equals 2. That would be 2 and 2. That definitely equals 4. If n equaled, say, 5, then we could have 5 and add 2 onto that. That's 7. It's always going to work, So plus 2. Next one. This one, example 3 says, write an expression to show the sum of m and k. So I think this is one of the easier ones altogether. It's just, remember that sum means addition, so it would be m plus k. This is an expression. Remember, no equal signs. So expression, no equal signs. An equation or a number sentence could have equals. And which property can be used in examples 1 to 3 that both expressions are given are equivalent? And these would be the, additive, I would say the additive, should really be the commutative property of addition, but I gotta go back in a video. So the commutative property of addition. And 4, how can we show 10 minus 6? So now we're getting into subtraction, and so this can be a little bit more confusing. So the bar diagram could say, here we're going to start with 10, right? We have 10 of something, so here I have 10 little boxes, and I'm going to take 6 away. So I'm going to actually find 6 of them. 1, 2, 3, 4, 5, 6. And I'm going to kind of take those away. Or you could kind of show this as 2 steps, and you could show, the 10, and then you could show, this way, you could say like that. Okay, so no, first we have, first we have a 10, and then we're going to take 6 of those away. We're going to break it up. And so the only expression that would represent this model would be 10 minus 6. Now we can't use 6 minus 10 because that would be like you have 6 things and then you're going to take away 10. Well, first of all, there's not even 10 to take away here. So you'd actually be getting negative amounts, or kind of like going in debt. If you only have $6, you can't give someone 10. So it doesn't work. You have to be real careful with the order because subtraction doesn't have the commutative property. And so 5, how can we write an expression to show 3 less than a number? So let's just pick some number. So I'll say 10. That's easy enough. So here we have 10. So here I have a diagram showing 10, and I'm going to take 3 away. So I'm going to take these 3, get rid of them, or I'm going to get rid of those 3. And so you could be thinking, okay, well, 3 less than 10, that's going to be 7, right? So we're definitely taking 3 away. So it says, are we taking away 3 or the unknown number? We're taking away 3. We're removing, we're saying we're going to get rid of this 3. So that expression would be 10 minus 3. Sorry, actually that would be for this. But if we just want to write an expression, then a better expression would be the number minus 3. And that would work for anything. You want the expression to work for anything. So this works for 10. So if my number is 10, 10 less than 3 is 7. And this diagram, this kind of proves that. But you could also pick a different number. What if your number was 5? Well, 5 minus 3 is 2 is, and then if you think, what's 3 less than 5? Well, 3 less than 5 is 2. So it works. A lot of times you just kind of have to think about it, go back and forth, and see what works. And then the last one's, how could we write an expression to show a number C being subtracted from the sum of A and B? So a lot of times what can be helpful is to write, we have the sum of A and B over here, and then C being subtracted from that. So the sum of A and B we could write as A plus B. We're just adding those together. And then C is being subtracted from this. So does that mean that it's C minus A plus B, or is it going to be A plus B minus C? So we did this part. Start off by writing an expression for the sum of A plus B. I wrote that up at the top. That's A plus B. And so C being subtracted from that, first we'd actually have to figure out what this is. And then if we're subtracting C, we are taking C away. So that has to come second or after. So we would want A plus B, and then we're going to take away that C from there. And if I want to get even more fancy, I could put parentheses around that to kind of make it even more separate, although it doesn't really matter because you do order of operations from left to right. The alternative way, the wrong way, would be is if you had said C minus A plus B, and this wouldn't work for a few reasons. The first reason is this is saying first start with C and then take away A from C and then add B onto that, which doesn't work at all. But if I put this in parentheses for the sum of A plus B, this still wouldn't work because this is we have some number C and we're going to take away from it A and B. And this doesn't say that. This says C is being subtracted, or C is being taken away from A and B. And lastly, we have write an expression to show the number C minus the sum of A and B. Well, hey, I just did that up here and said that. So that is just going to be down here. So this is the number c minus the sum of a and b. A plus b. And this has to be in parentheses. It has to be in parentheses because, just like I said, if that's not in parentheses, then we're not actually going to add that together. If this isn't parentheses, then we don't have to do this first, so it's actually c minus a, and then adding the b. We want to figure out what this is. We want to find the sum of a and b, and then take that whole thing away from c. So that's kind of like, I would summarize that in your own words down here, right here, something what I said. And then down here, we can check it. So replace the variables, replace the variables with the numbers to see if c minus the sum of a, b is the same as c minus a plus b. The easiest way to do this would just be to pick a number for a, b, and c. So a, b, c, I'll say 2, 3, and 4. So I don't like to use 1 when I'm checking things, because sometimes 1, you multiply by 1 and it can get a little tricky. But this first one would be 4 minus 2 plus 3. And that would be 4 minus 5, which is actually negative 1. And then the other way would be c, I need to use the letters, 4 minus 2 plus 3. That would be 2, because you do this part first, plus 3, and that would be 5. So you can definitely see where the parentheses change it, because 1 gives us negative 1, and 1 gives us 5. So that's all. You survived. Have fun. Okay, bye.